And the reason why I couldn't figure out what the heck was a wave is that when I'm the type that observed nature. And so I would like observe nature, and in nature I didn't see anything going up and down like this. And the physics book kept on saying very basically that everything was a wave, right? And it's like, well, if everything is a wave, why isn't everything moving up and down like this? You know, traveling through space up and down like this. And, you know, I couldn't figure it out. I was like, oh my God, what is this wave thing? And it was giving me a headache. And I was like studying for months trying to figure out the wave. And finally I got frustrated and I thought, well, I'm going to go back to point zero. Forget all these physics books. And I just hopped in my van, went to a high lake in Canada. You know, I lived in Canada at the time. And I went to one of those like turquoise lake in the high mountains of British Columbia, which has, you know, which is like really, really flat. And I grabbed a rock and I threw it in the lake. And I'm like, I'm going to start with point zero. What the heck is a wave, right? So I threw it in the lake, and the rock hit the surface tension of the water, and sure enough, the waves came off, and I could see that if you bisected the waves, you would get this up and down motion of a sine wave. But something was not quite right. If you have this up and down motion of the wave, it's only a result of that rock hitting the surface tension of the water and pushing the molecules away. So you have to account for that force too, of the rock going through the water. So if you account for the causation of the wave and the wave, then you get a different model. You get a model of like more of a cone, because the rock is sinking and the wave is going out. And that's when it hit me. Oh my God. I realized what had happened. This is this two-dimensional problem again. Guess what? Our universe is not on the surface screen of an oscilloscope. Our universe is in spherical coordinates out here, okay? And so what happened is that because physicists and mathematicians are really not good in dealing with rotation and angular momentum, torque and Coriolis effect and all this, they flattened the wave. They made it like this. So what I did when I had this elimination of the cone, I went to the side of the lake on the sand and I drew a wave with a stick, but then I put a line through it like this, and I realized that the wave is actually a 3D vortex. Can everybody see that? And I was like, oh my God, they flattened the wave. That's why I'm confused. Nothing in the universe goes up and down like this. Everything in the universe orbits and rotates. This is when this is one of the reasons that Einstein field equations are not complete. It's because the torque and the Coriolis effect that's resulting from rotation is eliminated by attaching the frame of reference to the rotation of an object. When they calculate the forces involved in a black hole that's rotating, they attach themselves to the black hole so that they're rotating at the exact same rate, so they don't have to deal with torque. Go ahead.
Does rotation have something to do with time and the way time is interacted with?
Yeah. and we're going to see that in a minute. So, you know, imagine that there is, I'll give you a simple example. Imagine that there's an electrical motor turning in front of you, and there's a shaft, and you're going to try to grab that shaft, right? Now, if you grab that shaft and you're, you know, you're not moving with it, you're going to get heat, you're going to get torque, you're going to get all sorts of effects, right? Thermodynamic also. Your hand is going to start shredding, right? Okay, but if you turn with the shaft, then there's no force. You see? Now that's a big difference. Okay, if you're calculating things where things are turning with, if the observer is turning with the thing, then you're going to miss a lot of forces. Imagine, for instance, calculating the forces that are going on in a galaxy. 300 billion stars orbiting, right? But instead of being an observer looking at the object orbit, you're attaching yourself to it, then there's not going to be any forces. That's a big omission in current physics. But what happened there is that I realized that the waveform is not a thing that goes up and down like this, but actually a thing that goes in orbit. And when you look at it that way, then the wave frequency, the wave amplitude, and the wavelength are all a result of angular momentum, rotation. You see? That not being accounted for. When you look at the sun and you imagine the electromagnetic field of the sun coming towards you, typically you're imagining something coming towards you like this, right? But actually it's coming towards you like this, right? And so I was excited about that. I'm like, oh my God, okay, this works. It's a vortex. And then I was leaning back on the sand, and I was looking at the sun go behind the mountains as it was setting. And I thought, isn't it cool how we always think the sun is like setting, but actually it's the earth that's turning? And as I thought that, I had another illumination. Oh, mechanically. And I thought, wait a minute. We've all been taught in our current understanding that the sun is here in the center of our solar system, right? Since Galileo and Copernicus. And that the planets do something like this, right? Is this true? No. That actually has nothing to do with the dynamics of our solar system. Although this is taught to all children at school. Even in my school there was like one of those little devices, you know, that you turn the little thing on the bottom and the planets go around the sun. I don't know if you had those, but I had those in my school. And it's actually completely incorrect. Here's our closed, isolated system biting us in the butt again. Because the sun is moving 200 kilometers per second. And the planets are following at the equator of the sun, generating a huge vortex that has nothing to do with planets coming back onto themselves over and over again. See how different that view is just from not going with a closed system? Right? And I realized it's all vortices. Now, when you look at it, you could say this is 2000, This is 2001.